Greetings everyone and welcome to Cyber Hashira. Today's video is about generating keys using PKCS 11. Keys are essential if you want to sign or encrypt some data. I will talk about functions to generate a symmetric key, an asymmetric key, and a data object. Now let's jump in and learn about those functions. Before I dive into today's topic, I want to express my sincere thanks to everyone who helped me grow this channel. We have reached over 1,000 subscribers and this wouldn't have been possible without you. I really appreciate all your support. Thank you. These are the 6 functions in PKCS 11 that can generate various objects such as secret key, a private key, a public key, and a certificate. They also include session objects and token objects. Let's talk about these functions. C generate key generates a secret key such as AES or ECDSA and returns an object handle upon its successful execution. C generate key pair generates an asymmetric key such as RSA or DSA and returns an object handle for private key and a public key. C create object is used for creating objects with known values. The objects created using C create object can be customized. C derive key function is used for key derivation, which involves deriving a key from a base key. I will discuss this function further in a separate video. C unwrap key is used for unwrapping an encrypted key. Wrapping and unwrapping are techniques used for exporting and importing a key. I will make a separate video on this topic. C copy object function does not generate or create a new object. It simply copies an existing object. Now, during the copying process, you have the option to modify the object attributes. I will cover this topic in another video. In this video, we will focus on C generate key, C generate key pair, and C create object. I'll start with the function C generate key. This function is used for generating secret keys like AES and ECDSA. This function takes 5 arguments and the first argument is of type CK session handle. This is the handle number of the session where C generate key will be processed. The second argument is of type CK mechanism PTR. It is a pointer to a variable which has information about the mechanism to use for generating a secret key. The third argument is of type CK attribute PTR. It is a pointer to a variable that holds a set of attributes. These attributes together are also known as a template. This template will be used to set attributes to a generated key. Fourth argument is of type CK ulong. This argument holds the count of the number of attributes passed in the attribute template. The fifth argument is of type CK object handle PTR. This is a pointer to a variable that will store an object handle. After a secret key is generated, the object handle number of that key will be stored in that variable. And these are some of the return values that C generate key is expected to return. I have made a separate video about return values, so I'm not going to explain them in this video. Page 175 of PKCS 11 manual has the complete list of return values that C generate key is expected to return. Moving on. The next function I'm going to talk about is C generate key pair. This function is used for generating asymmetric keys or key pairs. It takes 8 arguments. The first argument is of type CK session handle, used for passing a session handle number. The second argument is of type CK mechanism PTR. This argument is used for setting the mechanism for generating a key pair. For example, RSA, DSA, and ECDSA. Attribute template for a public key is expected as the third argument for C generate key pair. Anything other than the public key template would cause this function to fail. Fourth argument is the count of number of attributes passed in the public key template. This attribute is of type CK ulong. And the fifth argument takes the attribute template for a private key. Anything other than a private key template would cause C generate key pair to fail. This argument is of type CK attribute PTR. The sixth attribute is of type CK ulong. This attribute holds the count for the number of attributes in the private key template. Seventh attribute is of type CK object handle PTR. This would be the pointer address for the variable which would store the public key handle. And the last attribute is also of type CK object handle PTR. This would hold the pointer address for the variable that would store the private key handle. These are some of the return codes that C generate key pair might return. Complete list of expected return codes is available on page 177. The next function I'm going to talk about is called C create object. This function is used for creating an object with a known value instead of letting a cryptographic engine or a module to generate it for you. For example, if you know the value of a secret key, then C create object can be used to create a secret key with that known value. Objects created by C create object can be a private object or a public object. It can also be a session object or a token object. Objects created by C create object can belong to any class. It can be a secret key, public key, or a private key, or even a certificate. There are some hardware security modules that disallow C create object from creating a private key and secret key. C create object accepts sensitive values in clear, so there's always a risk of those sensitive keys from getting leaked or compromised or getting revealed. This restriction also prevents weak private keys and secret keys from getting into hardware security module. An object created by C create object function will always have CKA local attribute set as false because that object wasn't generated by the cryptographic module. Because a known value was used for creating an object, CKA never extractable will be set as false. And for that same reason, CKA always sensitive will also be set as false. Let's now look at how C create object function is defined in PKCS 11. C create object takes 4 arguments, first of which is of type CK session handle containing the session handle number. Second attribute is of type CK attribute PTR. This argument takes attribute template for the object you want to create. Third argument is of type CK ulong. This is the size of the attribute template. And the fourth argument is of type CK object handle. This has the pointer address of the variable that will store the object handle number. Return values expected to be returned by C create object are the same as the ones returned by C generate key and C generate key pair. You can view the complete list on page 128. For this video, I have prepared 5 sample codes. These are written using C++. 2 sample codes will show how to use C generate key function of PKCS 11. And these 2 samples will show how to use C generate key pair function of PKCS 11. And then I have 1 sample code that shows how to use C create object. Let's start with generate des3 key.cpp. If you have watched my previous video, you would see that most of this code is the same as the one that I wrote for my other PKCS 11 video. So I'm not going to explain all of this. I'll just show you the things that I've added. So one of the things that I've added is a variable over here called obj handle. This variable is of type CK object handle, and I've initialized it as 0. So I will be using this variable to store the object handle number of the des3 key that we will be generating. Let's scroll down. So most of it is the same: connect to slot, disconnect from slot, and this is the function that I have added. This function is called generate des3 key. The purpose of this function is to generate a des3 key with the following properties. This key is going to be a token object. It's going to be sensitive, read-only. I will not be able to extract this key. I can use this key to encrypt and decrypt some data, and it's going to be a private object. Inside this function, I have declared a variable called mech. This variable is of type CK mechanism. CK mechanism in PKCS 11 is used to specify a mechanism which I want to use with a function. Currently, the value of mech is set to CKM des3 key gen. Now, here's something you need to know about mechanisms. If you ever see a mechanism that ends with either keygen or key pair gen, then that's a clear indication that I can only use that mechanism for generating a secret key or maybe a key pair. For example, so I have the PKCS 11 manual open. I'm on page 377, where you should be able to find the list of all mechanisms in PKCS 11. It's a long list. Now you would notice that some of these mechanisms, they end with key pair gen or maybe keygen. So if you see a mechanism that ends with keygen, that means I can use that mechanism to generate a secret key. And if you see a mechanism that ends with key pair gen, that means I can use that mechanism to generate a key pair or an asymmetric key. All right, let's get back to the code. There are three more variables that I've declared. There's a variable called yes and no, and both of them are of type ckbbool or boolean. The value of yes is set to ck true. Value of no is set to ck false. Then there's a variable called label, which has a value des3 underscore key. So once this key is generated, it's going to have a label called des3 key. And then I have the attribute template. So this is the complete template. This is an array which has a list of all attributes that I want to set to the des3 key that I will be generating. You would notice that CKA token is set to yes, and the value of yes is true, which means I will be generating this des3 key as a token object. This key is going to persist in the slot. Private is also set to yes, which means I have to be authenticated in order to access this object. This key is sensitive, which means I will not be able to read any sensitive value of this key. I will not be able to extract this key because the value is set to no. And I will not be able to change any properties of this key because CKA modifiable is set to no. And that's why this key is read only. And after that, I have set encrypt and decrypt as true. So I should be able to encrypt and decrypt once this key is generated. And finally, we have the label, which is going to be des3 key. Then we have a variable called attrib_len. This is of type ck_ulong. This variable is going to store the count of number of attributes in this variable. So in total, we have 8 attributes. So the value of attrib_len is going to be 8. And then finally, I'm calling cGenerateKey function. And the first argument that I'm passing in this function is hSession. This variable has the session handle, which I will be using for generating this des3 key. The second parameter is the mechanism. So I'm telling cGenerateKey to use this mechanism. The third argument is attrib. I am telling cGenerateKey to use the following properties or following attributes for this des3 key. The value of attrib_len is going to be 8. So I am telling cGenerateKey that the list of attributes that I've passed will have 8 attributes in it. And once the key is generated, the object handle number will be stored in a variable called objHandle. And once this function executes successfully, I should be able to see an output that says des3 key generated as handle. and it will display the handle number of that des3 key. Let's go ahead and execute this code and show you how it works. So I'm going to exit out of this. To compile this code, I would run the command g++, the name of the source code, so it's generate des3 key, and I want to output it into des3 key. I'm telling GCC to include all headers in the include directory, and this is a sample that I'm executing on Linux environment, so I'm passing nix. I'll hit enter. Okay, this is a syntax. Okay, let's get the slot numbers. So show slots. Here's a slot number. So generate, paste, normal user. Okay, 1 second. I need to export this environment variable. I'll just copy paste it. Okay, try again, or let me clear the screen and try again. Perfect. So this program worked, and we clearly see the output that says PKCS 11 library loaded, connected via session 1, and I'm sure using that session it was able to generate a des3 key with handle number 2, and once the key was generated, it disconnected from that slot. Let's use P11 tool to see if the key exists or not. So the syntax is provider .so, and I want to log in, list all, and here it is. So it's a secret key, and the label of this key is des3. Let's now look at the next sample, which generates an AES key. So the next sample we are going to look at is generate AES key.cpp. This sample is the same as the one that I used to generate a des3 key. I'm just going to show you the changes that I've made. Everything is same, and here's the function. So this is a function which I will use for generating the AES key. The key that I will generate will have the following properties. It's going to be a token object. It will be private, sensitive. I can extract it. I can make changes to the key, and I can use that key to encrypt and decrypt some data. Inside generate AES key function, I have declared a variable called mech. This variable is of type CK mechanism, which is used for specifying the mechanism to use. The mechanism I'm going to use is CKM AES key gen. So this is a key generation mechanism. I also have two Boolean variables, yes and no. The value for yes is CK true. The value of no is CK false. And I have a variable called label, which has AES underscore key as the label, and I have declared a new variable called key size. This variable is of type CKUlong. The value is 32. I will be using this variable to specify the size of AES key that I want to generate. As you already know, AES key can be of size 16, 24, and 32 bytes. So I'm going to create a 32 byte key for AES. This is the attribute template, and inside this template I have set all attributes as yes. So token object yes, private object yes, sensitive, extractable, modifiable, encrypt, and decrypt, and I have passed the label, and here I have passed the key size. So I'll be using a new attribute here called CKA value len, which is used for specifying the size of a key that I want to generate. So CKA value len is of size key size, and key size is 32. And I'm calculating the size of this attribute template. So in total there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value of attrib len is going to be 9. And then finally, I am calling cGenerateKey function. I'm passing the session handle number, the mechanism, which is CKM AS keygen, the attributes or the template that I've declared here, the length of this template, which is going to be 9. And once the key is generated, the object handle number of that AS key will be stored in obj handle. And if everything works well, I should see an output that says AS256 key generated as handle and the object handle number. Let's execute this code and see how it works. First, I would compile this program using the command g++ generate AS key, and I'm going to output the binary into a file called generate AS key. And I want to include the headers in the include directory and Linux because I am using a Linux environment. Okay. So HSM util go slots. Okay, this is a slot number that I want to use. So generate AS key. Here's a slot number. And here's the password. And it says AS256 key generated as handle 2. I will now execute P11 tool. I want to see if that object is created or not. So provider is going to be softhsm lib softhsm. This is a PKCS 11 library. Login and list all. Okay, so here's the des3 key from the previous sample, and here's the AS key that we just created. Let's now take a look at our next sample. It's called generate RSA key pair. So in this function, I will be using cGenerateKeyPair function, which is used for generating key pairs, and I will be generating RSA key pair in this sample code. Most of the sample is same, so I'm just going to point out the changes. Okay, so we have two variables, which is of type CK object handle. H public is going to store the public key handle. H private will store the private key handle. Let's scroll down. And most of it is same. And okay, so this is a function which is going to generate the key pair. The key pair is going to be of size 2048. Inside this function, I have declared a variable called mech. Mech is of type CK mechanism, and the value that I've specified is CKM RSA PKCS key pair gen. I'm sure you must have noticed it says key pair gen, not key gen, which means this mechanism will generate a key pair. I've also declared two Boolean variables, yes and no. Yes has the value set as CK true. No has the value set as CK false. Then I have declared a variable called key size, which is of type CK ulong. This variable has value 2048. This is going to be the modulus of RSA key pair that I will be generating. I also have another variable called public exponent. This is going to have the public exponent of our RSA key pair. So the value is 65537. This is the hex representation of 65537. This variable is of type CK byte. It's a byte array. And then we have two other variables called pub label and pry label. Pub label will have the label for the public key, which is set to RSA underscore public. Pry label is RSA underscore private. That's the label for the private key. And because we are generating a key pair, there's going to be two objects. So there's going to be a private key and a public key. So we need to use two templates. One template is going to be for our public key and the other one will be for our private key. Let's talk about our public key template. Public key template has CKA token set as yes, CKA private set as no. This public key should be able to verify signed data. It should be able to encrypt data. The modulus is set to 2048. Public exponent is set to 65537. This is the hex representation. And the label will be set as RSA underscore public. And then below that we have another variable which is of type ckulong attrib len pub. This variable will store the length of this template. So in total there are 7 attributes. So attrib len will have 7 as its value. And then below that we have the template for our private key. This is going to be a token object. It's going to be private. This private key should be able to sign some data. It should be able to decrypt some data. It's a sensitive object. And the label of this private key will be set as RSA private. And below that, we are calculating the size of this template. So attrib len private, which is, or attrib len pri, which is of type ckulong, will have a value of 6. And then finally, we are calling the function cGenerateKeyPair. The first argument inside this function is our session handle, hSession. The second argument is mech. Mech has been specified as ckm RSA PKCS KeyPair Gen. The third argument is attrib pub. This is the template for our public key. And then we have attrib len. This is the length of the public key template. Then we have attrib pri, which is our private key template. Attrib len pri is going to be the length of this template that we calculated here. H public will store the handle number of our public key, and H private will store the handle number of our private key. And if all goes well, we should see a message that says RSA key pair generated as handle, and it will display the handle number of public key for public key and handle private for a private key. All right, let's compile and execute this sample. Okay, so first I'll start compiling this code. So generate RSA key pair. This is the sample, and I want the output to be this. Include all header files in the include directory -dnex. Okay, program has been compiled, and let me get the slot number. Okay, this is a slot number. So generate RSA key pair, paste the output, normal user, and RSA key pair is generated. I will now run the P11 tool, or let me clear the screen. Okay, so P11 tool, provider, soft-hsm, lib, soft-hsm. Okay, this is a file. Login, list all. And okay, so AS key, desk key, RSA private key, and RSA public key. Very good. Let's look at our next sample. Our next sample code is called generate ECDSA key pair. This is a sample that I have prepared to demonstrate the usage of cGenerate key pair. This sample will generate ECDSA key pair using PKCS API. Most of the things in this sample are same. So we are going to generate a key pair. That's why I have H public and H private declared here. H public will store the public handle number, and H private is going to store the private handle number, or I should say private key handle number. Let's scroll all the way down. Okay, so this is the function. Generate ECDSA key pair is the function which will generate ECDSA key pair using this curve, SECP384R1. I have a variable called mech, which is of type ck mechanism. The value assigned to this variable is ckm ECDSA key pair gen. Then we have two Boolean variables with the value ck true for yes, ck false for no. And I have two labels. So the labels for the public key is going to be ECDSA public, and the label for the private key is going to be ECDSA private. Now this is the main part. So I have a byte array here called curve, and this has the hex representation for this curve SECP384R1. This is a hex representation. If you want to use some other curve, let me show you how you can generate this. So I'll just go out of this sample. We can use OpenSSL to do this. If you want to get the list of all available curves, then you can simply run the command OpenSSL ecparam-list _ curves. And this is going to display the list of all available curves for ECDSA. And you can just pick whichever one you want. Let's say, for example, you want to generate a hex representation for prime 256v1. Let me clear the screen. Okay, so to get the hex value for that curve, we will run the command OpenSSL ecparam-name, paste that curve, and then set the output format to dir. This is going to be binary. And I will pass this output into XXD. And this is going to display the hex representation for prime 256v1. Let me change it back to the curve that I was using in the sample. So SECP384R1. Okay, so this is the curve. Let me copy this. Okay, go to generate ECDSA key pair function. And I'll just paste it here so you can see. So as you can see, 06, 05, 2B, 81, 04, 00, 22. I hope this process is clear to you. If you have any questions, you can post those questions in the comment section. Once I have the byte array for our ECDSA curve, I will be passing this byte array into an attribute called CKA ECParams. So I have a template. This is a template for the public key, and this is a template for private key. In the public key template, I have set CKA token as yes. Private is set to no. This public key should be able to verify signed data. It should be able to encrypt some data. The ECDSA param has been set to the information that we passed here. This is for SEP384R1. And the label for the public key will be set to ECDSA public. And below that, we have a variable called attrib_len_pub, which is going to have a value of 6. And then below that, we have the template for our private key. Private key has token set to yes, private set to yes, sign, decrypt, and sensitive, they're all set to yes. And the label is going to be set as ECDSA private. And just like we did for generating RSA key pair, this is the same format. So we are calling cGenerate key pair function. The first argument in this function is our session handle. The second argument is the mechanism that I want to use. So this mechanism is going to be CKM ECDSA key pair gen. The third attribute is going to be the public key template. Then we have the length of that public key template. Then we have the private key template, this one. And then the length of that private key template. Then we have the variable which is going to store the handle number of our public key, and another variable which is going to store the handle number of our private key. And if all goes well, it's going to display a message that ECDSA key pair is generated, and it's going to display the handle number. Okay, let's execute this sample. Let's compile this program. So G++ generate ECDSA key pair. and I'm going to output it into this file, include headers from include directory, dnex. Okay, program compiled. 1 second, I keep losing my slot number. Okay, so generate ECDSA key pair, paste the slot number, and normal user as the password. And it says ECDSA key pair generated. Let's clear the screen. I'll use P11 tool to see if those objects are created or not. Provider libs of HSM. Yes, so. Okay, so ECDSA public and ECDSA private. And the last sample which I want to discuss with you today is called create object underscore data.cpp. The purpose of this sample is to show you how to create a data object using c underscore create object function in PKCS 11. A data object is used for holding some information which an application can use when required. This information may be something related to an application, or it could be a seed value. It could be anything. In this sample, I mean, most of the things are same. So I'm just going to talk about the changes that I made. So we have create data object function. Inside this function, we have two Boolean variables. Yes has the value ck true, no has the value ck false. We have a variable called label. So once this data object is generated, it's going to be identified as label a underscore data underscore object. The value of this data object is going to be set as serial. I mean, this is just a name that I've given. And this is just a random hex data that I've generated. I'm going to pass this hex string as the value for this data object. I've also declared a variable called obj class. This variable is of type ck object class, which is used for specifying the class of an object. And the class of the object which I want to use is called cko data, which means it's a data object. Let's talk about the attribute template. Inside attribute template, I have specified CKA class as CKO data. So I'm passing obj class, and the value of obj class is CKO data. CKA token has been set as yes, CKA private yes, CKA modifiable no, which means I will not be able to make changes to it once this data object is created. The value of this data object is set as the randomly generated hex string, and the label is going to be set as a data object. After this, I am calculating the length of this template and storing the value into attrib len. So this is going to have the value of 6. There are 6 attributes. And then finally, I am passing all this information into c create object function. The first argument inside c create object function is a session handle. So each session holds the session handle which I want to use for executing c create object. The second argument is attrib. So this is going to be our attribute template. The third argument is the length of this template. And the last argument is the variable which is going to hold the handle number of this data object. And finally, when this function is executed, it's going to display a message that says data object created as handle, and it's going to display the handle number. Let's execute the sample. To execute the sample, I will run the command g++ create object, output this into create object, include everything from include directory, dnex. Let me get the slot number. So show slots. Here's our slot number. So create object, slot number, and the normal user password. And it says data object created as handle2. Let's clear the screen. P11 tool, provider, OPT, soft HSM, lib, soft HSM. Okay, this is a library. Login and list all. And where is it? Why can't I find it? Okay, here it is. So data object, this is a data object that we just generated. And this is a complete list of all objects that are currently stored in token 01. That's it for this video. I hope I have shared enough information about generating keys using PKCS 11 API. If you have any questions or need help, please don't hesitate to reach out in the comment section below. You can also find the sample codes I used in today's video on my GitHub page. Thank you so much for watching. If you found this video helpful, then please don't forget to leave a like and consider subscribing to my channel if you're not subscribed yet. Take care.